Hello, my name is Hanna Szkudlarek, and today I would like to talk about cognitive impairments induced by adolescent THC exposure and how they can be prevented by antioxidant treatment. Cannabis plant is most widely used illicit substance in the world, and the most prevalent bioactive constituent is tetrahydrocannabinol, THC. Previous studies have shown that exposure to THC during adolescent period may lead to developmental changes in multiple neurotransmitter pathways, aberrant THC, and impairments in condition, to name a few. Moreover, adolescent THC use increases the long-term risk of psychosis compared to non-users. It is suggested that oxidative stress might be underlying reason of multiple psychiatric disorders, and recent preclinical studies shown that antioxidant treatment prevented adult deficits in a developmental model of schizophrenia. Since THC exposure leads to increased production of hydrogen peroxide and free radicals, we hypothesize that oral administration of antioxidant and acetylcysteine, in short NAC, in parallel to adolescent THC treatment, may prevent the development of cognitive deficits at adulthood. For this study, adolescent Sprague-Dawley rats were treated with increasing doses of THC and underwent oral antioxidant treatment for additional 2 weeks. Following, adult animals were tested with multiple behavioral tests and electrophysiology. First, we use novel object recognition test, where animal is placed in the arena with 2 similar objects and returned to the arena 1 hour later, but this time one of the objects is new. This test relies on the natural attraction of rodents to novelty. We showed that only THC animals displayed impaired object preference and lower recognition score, while exploratory functions were unaffected. Please note that the percentage of rats displaying preference towards newer objects was reversed with THC treatment, but normal in both NAC groups. Similarly, testing animals using object recognition in temporal order yielded similar results. Here, the object that was explored earlier versus more recently would be more attractive to rodents. Only THC animals showed impaired object recognition, as evident from paired t-tests and lowered recognition score. Again, the percentage of animals preferring more recent objects was increased only in THC group, but not in NAC groups. Next, we perform social interaction test, which utilizes natural propensity of rats to interact with another animal rather than with objects, called social motivation, and to interact with stranger rat versus familiar one, called social recognition. The social motivation was similar across groups, however, social recognition was impaired only in THC-treated animals. Again, there was no preference towards novel versus familiar rat in paired t-test, and social recognition score was significantly lower when compared with control. Importantly, NAC was able to prevent this impairment. Following, we assessed attentional flexibility using operand boxes. First, animals were trained to press the lever in order to get a reward and associate that only pressing the lever highlighted with the light would be rewarded. Successful learning was defined as 10 consecutive correct lever presses. Although THC treatment did not affect performance, vehicle NAC-treated animals learned faster, suggesting positive effect of antioxidant on learning. Importantly, the memory was persistent, and when animals were tested the following day, all groups performed similarly. Next, the rule was changed, and rat needed to always press the left lever independently of light position in order to get the reward. Here, there was no differences between the treatment groups, and all animals were able to switch to the new rule. However, when the rule was changed again, and now the correct lever was the opposite one, the number of trials and errors to employ new strategy was significantly higher for THC-treated animals. As evident from the average cumulative responses, learning in THC animals was delayed. Also, the percentage of animals that did not reverse was higher only in THC group, suggesting that adolescent THC impairs flexibility and not restores it. Pre-pulse inhibition, PPI, is a neurological phenomenon in which a weaker pre-stimulus inhibits the reaction to a subsequent strong stimulus. Deficits of PPI manifest in the inability to filter out unnecessary information and are present in schizophrenia patients. We show that PPI in THC-treated rats was reduced. Moreover, THC rat displayed decreased acoustic reactivity, and the percentage of animals that did not habituate was larger only in THC group. This suggests adolescent NAC treatment reversed THC-induced impairment of sensor processing. Finally, we compared treatment-induced changes in local field potentials recorded in prefrontal cortex. We showed that THC treatment comparing to control rats affected only gamma oscillations, manifested with increased gamma power, and that this imbalance was reversed with NAC treatment. We conclude that adolescent THC impairment treatment might increase mitochondrial free radical leak, leading to neuronal damage and cognitive impairments, while concomitant NAC treatment prevents the damage caused by oxidative stress and leads to normal cognition. I would like to thank all the people who contributed to this work and funding agencies supporting this study. Thank you.